So today we're going to do some revision on chemical reactions. So being able to tell the difference between chemical reactions and physical changes, and then looking at the reactions of acids, which hopefully should be revision for all of you. Okay, so here we have a selection of pictures. Some of them show chemical changes and some of them show physical changes. What I'd like you to do is try and put them into two groups based on which are physical changes and which are chemical reactions. So pause now and have a go at that. Okay, so well done if you got these right. You can see that burning wood, metal rusting and the egg frying are all chemical reactions, whereas melting, freezing and dissolving are all physical changes. A chemical reaction occurs in the examples on the left when reactants, the chemicals taking part in the reaction, so in the case of burning wood, that's wood and oxygen from the air, react and turn into new chemicals called the products, in the case of the wood burning, carbon dioxide and water. Whereas in a physical change, you can reverse the process and the chemicals themselves haven't changed into new products. So if you melt water, you can refreeze it. If you freeze water, you can melt it. If you dissolve salt into water, you can boil off the water and get the salt back. So the chemicals haven't changed. Pause now and see if you can write your own definition of a chemical reaction. Okay, so hopefully you've written down a definition of a chemical reaction. You can check it now against this one. So a chemical reaction is a process in which one or more substances, the reactants, are converted into one or more different substances, the products. So the key here is that the reactants, the chemicals you start with, have changed in. So now we're going to have a look at some examples of chemical reactions that you will have learnt about during year 8 and just go over them so you can revise them. So the first is the reaction between metals and acids, and you might remember doing this in class as an experiment. You would have tried different metals in dilute acid, and in terms of what you'll have been allowed to do, magnesium would have been the most reactive. You'd have seen lots of bubbles and fizzing, and you might have felt the test tube get quite hot. Iron is less reactive and lead even less reactive. Copper doesn't really react with water, and sodium you may have seen demonstrated by your teacher. Sodium whizzes around on the surface of the water and produces lots of gas. You may remember doing something called the squeaky pot test, which you can see here in the second diagram. So you will have collected the gas given off by the reaction and placed a lit wooden splint into the neck of the test tube, upon which you'd have heard a squeaky pop. You might remember which gas this was testing for, and we're going to have a look at that on the next slide. Okay, you might also remember writing some equations for the reactions of metals and acids, and you can see at the top here that when a metal reacts with an acid, you get two products, salt and hydrogen. The colour coding shows you where the name of the salt has come from. So the first half of the name comes from the metal and the second half comes from the acid, and you will always produce hydrogen gas. That's the one that gives you the squeaky pop when you put the lit splint into the neck of the tube. So for example, you can see that magnesium and hydrochloric acid react to produce magnesium chloride and hydrogen. The salt, so the first part of the name of the salt has come from the metal, so you can see both of those are in blue. A chloride salt is formed when hydrochloric acid is used. So magnesium chloride comes from the magnesium and the hydrochloric acid. You can see some symbols underneath there just so you can see what's happening. In our next example, calcium and hydrochloric acid will produce calcium chloride, because we've used hydrochloric acid again, and hydrogen gas. If you use nitric acid, your salt will be called something nitrate, and if you use sulfuric acid, your salt will be called something sulfate, the something being the name from the metal. So I want you to have a go at finishing these equations and see if you can name the salts. So have a go at the first one. Okay, so first job is to rewrite the name of the metal on the right hand side of the arrow. So we're starting with calcium. Because we've used nitric acid, our salt is a nitrate salt, so the salt is called calcium nitrate. And in each of these reactions, your other product will be hydrogen. Okay, so have a go at the two examples below. Okay, so hopefully you've had a chance to have a go at number 3 and number 4. So calcium and sulfuric acid should give you calcium sulfate and hydrogen. Zinc and hydrochloric acid will give you zinc chloride and hydrogen. Well done if you got those right. So the next reactions that we're going to look at are the reactions between acids and metal oxides. Metal oxides are metals where they've reacted with oxygen. So you can see two examples at the top here, so calcium oxide and magnesium oxide. When they react with acids, they form a salt again, but this time instead of hydrogen they form water. So metal oxide plus acid gives salt and water. We name the salts in exactly the same way as we did with the acids and metals. But instead of hydrogen you get water. So copper oxide and sulfuric acid, we are going to get copper sulfate, copper from the metal, sulfate because it's sulfuric acid, and water. So I want you to have a go at the next three and see if you can name the salts and include the other product in those. So hopefully you've had a chance to have a go at those. So magnesium oxide and nitric acid are going to give us magnesium nitrate and water. Silver oxide and hydrochloric acid are going to give us silver chloride and water. Lead oxide and sulfuric acid are going to give us lead sulfate and water. So again, well done if you got those right. Okay, so one more set of reactions that we're going to look at today. Metal carbonates and acids. So a metal carbonate is just a chemical that contains a metal, carbon and oxygen. So for example, calcium carbonate or chalk contains calcium, carbon and oxygen. Magnesium carbonate contains magnesium, carbon and oxygen. So when the carbonates react with acids, they also form a salt. However, they also form carbon dioxide and water because of the carbon that's in the carbonate. So when calcium carbonate reacts with hydrochloric acid, we get our salt, which is calcium, so the metal from the carbonate, chloride because it's a chloride hydrochloric acid, and so we get calcium chloride salt, carbon dioxide and water. So when we're naming these salts, it's the same as before. We take the metal from the name of the metal carbonate, the ending from the acid, so if you look at the bottom of the slide you can see which acids produce which salts, and name your salts. So have a go at the next two. Okay, let's see how you did with these. So sodium carbonate and sulfuric acid is going to give you sodium sulfate, carbon dioxide and water. Copper carbonate and nitric acid is going to give you copper nitrate as your salt, carbon dioxide and water. Okay, so what I'd like you to do now is have a go at these questions in the quick test. Write your answers down on a piece of paper because I'm going to put these questions into Show My Homework quiz, and you can use the answers that you've written down to go through and complete the quiz. Good luck.